Hello my dear young scientists. Till now we have learnt the differences in the properties of acids and bases according to their chemical reactions. Now we should see whether they have something in common. Do they have any property regarding electrical properties? For this purpose I have made one simple electrical circuit. You have learnt how to make electrical circuits in your previous classes. So, what do I need for this? I have got two nails, simple nails, a connecting wire, an LED and a battery to join the circuit, and right now the circuit is open, isn't it? If I touch this on the wooden table, the LED does not glow, but if I take this metallic spatula and touch it, obviously I knew it. The circuit is complete and LED starts glowing. Let us see what happens when I put this system in a dilute NaOH solution and then in a dilute HCl solution. What kind of results do I get? Let us have a look. Wow, the LED has started glowing. This means that the dilute NaOH solution conducts electricity. Why would it conduct electricity? Can you tell me? Obviously, because the circuit is getting completed. And who would be completing the circuit? Obviously, the movement of ions. So, there is some movement of ions in this solution because of which the circuit is completed and now the LED is glowing. So, now let us check the same thing in dilute HCl solution. But before we do that, I should wipe it off clean, okay, and dry it, because the ions from one solution can move to the another one and give me some wrong results, isn't it? So, now my nails are clean and dry, and I will repeat the same experiment with my electric circuit that we have prepared, the simple one. So, now let us put it in dilute HCl solution, and yes, the LED is glowing again. That means the circuit is complete. That means in dilute HCl solution also we have the presence of ions which are moving and completing the electrical circuit. The chemical properties of acids and bases were different, but the electrical properties, that is regarding presence of ions, is same. So, this experimentation tells us that both the solutions of acids as well as bases contain ions, because of which the circuit is completed and the LED is glowing. So, now the task is for you. I have shown you the process with dilute HCl and dilute NaOH solution. You can take up various solutions from the household like glucose solution, sugar solution or plain water, etc., and see whether the LED bulb glows. One thing that you have to remember, my dear students, is that the tap water that we get in our houses contains ions. So, it will conduct electricity and the bulb will glow. So, for this you will need distilled water, because distilled water does not have ions and it will not allow passage of electricity. And after doing all these experimentations, do not forget to make a table and record your observations. And the mantra that we always say, always record the correct observations. And if there is something and if it is not according to what you had expected, try and find out the answers to that. So, my dear young scientists, in the previous activity, we learned that all acids and bases in their aqueous solutions conduct electricity. That means they have ions. So, we need to learn and know that what happens when an aqueous solution of acid or base is made. So, let us try this. First of all, we should have a dry acid, and to produce dry acid, a sample, what we will do is, I will take some dry sodium chloride, the salt that we eat, okay, take it in a dry test tube, because we want to have a dry gas, okay, dry HCl gas, we are going to produce that. So, here we have dry sodium chloride in the test tube, okay, and to this we will add some concentrated sulfuric acid. Now, my dear students, this activity is not to be performed by you. This has to be a demonstration activity by your teacher, because concentrated sulfuric acid is very corrosive. It burns the skin, it burns the paper. Okay? So, we will use this concentrated sulfuric acid and very slowly by the sides, the walls of the test tube, we will pour this into the test tube. A little more. Now, this dry sodium chloride and the concentrated sulfuric acid in this test tube are giving me a reaction. A colorless gas is getting evolved. We cannot see it, but can smell it. Okay? And this colorless gas is HCl gas. Let us test with the blue litmus paper whether there is any color change. So, this is a dry blue litmus paper. We bring it near the mouth of the test tube. We will not touch the blue litmus paper to the mouth, because it might get wet. Okay? So, the dry litmus paper with the dry gas is not giving us any reaction. There is no color change. Let me now make this filter paper wet, because this was our task. We wanted to know what happens when an acid is dissolved in water. So, the gas I am not dissolving in water, but what I am doing is I am now making this filter paper moist, and let me put it on the mouth of the test tube. Wow, see, slowly the litmus paper is turning red at the positions where the HCl gas is touching the wet paper. That means the ions that we were talking about in the previous activity are released when there is a aqueous solution. Yes, now when the dry gas comes in contact with the wet blue litmus paper, the litmus paper is turning red. That means to release the ions from the acid, it required an aqueous solutions. So, our question was, what happens to an acid or a base in a water solution? That means in an aqueous solution. We can say that in an aqueous solution, the ions get separated. So, as you can see the reaction on the screen, the HCl gas, when comes in contact with water, it forms hydronium ions, that is H3O plus, and chloride ions. And what are these hydronium ions? The H plus ions, that is the protons, when they come in contact with water, they combine to form hydronium ions. Okay? Similarly, when sodium hydroxide, that is a base, is dissolved in water, it forms the sodium ions and hydroxide ions. Or if I dissolve potassium hydroxide in water, it will dissociate to give me potassium ions and hydroxide ions. Similarly, if magnesium hydroxide is dissolved, it will give me magnesium ions and hydroxide ions. So, we can conclude, my dear students, that all acids release H plus ions in aqueous solution, which combine with water to form hydronium ion. So, you have to remember, whenever you represent a H plus ion, either you write H plus aqueous or you write hydronium ion, because H plus alone cannot exist. Similarly, when you write about sodium hydroxide, potassium hydroxide, magnesium hydroxide, the OH ions, you write OH ions, and in the brackets you write aqueous, because it won't be possible for an OH ion to exist independently. Now, my dear students, we talked about NaOH, KOH, magnesium hydroxide, but I wish to bring to your notice one thing, that all bases do not dissolve in water. An alkali is a base that dissolves in water. These are soapy to touch, bitter and corrosive. And remember, never taste or touch them as they may cause harm. In fact, you should not taste anything that you do not know about. So, my dear young scientists, my students, we already know now that acids, when combined with bases, they give a neutralization reaction. They form a salt and water. But then, what do all neutralization reactions have in common? Now that we know that all acids produce H plus ions, or we can say hydronium ions in water, and bases produce hydroxide ions in water, the reaction becomes H plus ions aqueous plus OH ions aqueous, giving us water, and water we know is neutral. That is why it is a neutralization reaction. So, when water is mixed in acids and bases, what happens? One is that H plus and OH ions are produced. If we keep on adding water to acids or bases, will it impact the concentration? Yes. Mixing an acid or base with water results in decrease in the concentration of ions, that is the hydronium ions for acids and hydroxide ions for bases per unit volume. This process of decrease in concentration by adding water is called dilution, and the acid or the base is said to be diluted. What effect does the concentration of H plus ions have on the nature of the solution? Okay, yes, if there are H plus ions, it will make the solution acidic. Now, do you think basic solutions also have H plus ions? Yes, the basic solutions also have H plus ions. Then why are they basic? It is because the hydroxide ions are more in a basic solution. And my dear young scientists, we have to really see the symbols on the bottles of acids, bases and other chemicals. For example, this symbol that you see on the screen shows that the acid or the base or other chemical that you have is corrosive to skin, and you have to be really very careful while handling them. You have to remember that while diluting an acid, you should always add acid to water and not the other way round. That means, if you have to prepare a dilute solution of sulfuric acid, you will take some water in the test tube and then put concentrated sulfuric acid to that water. The reaction is highly exothermic and you have to be really very careful. Okay, now it is quiz time. Let us see whether you remember what we just learnt. Why do HCl, HNO3, H2SO4 etc. show acidic characters in aqueous solution? While the solutions of compounds like alcohol and glucose do not show acidic character, they also have hydrogen. Can you tell me? I think you can. That because HCl, HNO3, H2SO4, they will release H plus ions in the aqueous solution to form hydronium ions, but alcohol and glucose solution will not do that. Another question, why does dry HCl gas not change the color of the dry litmus paper? While diluting an acid, why is it recommended that the acid should be added to water and not water to the acid? Another question, how is the concentration of hydronium ions affected when a solution of an acid is diluted? I know you would be able to tell me that if we dilute it, the hydronium ion concentration would decrease. How is the concentration of hydroxide ions affected when an excess base is dissolved in a solution of sodium hydroxide. Now that we know that on dilution the concentrations of hydroxide ions and H plus ions change, but then how do we know that how much the change is there? For this, my dear students, we have this pH paper. A pH paper has got universal indicator impregnated on it. Okay? These are the strips of pH paper which are available in the market. We can take a strip of the pH paper and check the color change. After the color change, we have to match the color change with the strip that is there on the pH paper. Okay? So, if a solution shows a pH color change of 1, that means it is a very acidic solution. But if it shows a color change of dark green, then it is a highly basic solution. Let us check the color change of this universal indicator with some of the substances that I have with me here on the table, and the rest is up to you. You can check in your kitchen, you can check in your labs and see what is the color change to check out the pH of various substances. So, let us start our activity and record our observations. You have to always remember to record your observations at the same time. So, I have my solutions and yes, so a dropper for HCl and an NaOH, and I have my indicators put on this paper, and one by one let me put a drop on each of this. Yes, with HCl I have got a beautiful reddish pink color, orangish pink color, whatever you can say. With NaOH it is a dark greenish blue coloration, and let us check with this. With water, no color change as we had expected, because water is neutral. And then with sodium carbonate, a drop of sodium carbonate here. Yes, the color has changed to light green. And here I have acetic acid. We know acetic acid is vinegar which we use in food. So, will acetic acid be a strong acid or a weak acid? Obviously, if we are using it in our food, it has to be a weak acid. Let us see what is the color change. Okay, it has changed to a light pinkish orange coloration. So, as expected, the color change with dilute HCl is close to 1. It is highly acidic, and the color change with NaOH is close to 12 and 14. So, it is highly basic. The color change with water, obviously no color change, water is neutral. Now, I leave it to you. You can have the pH paper from the school, and you can collect various material from the kitchen or the school laboratory and make a table and compare the color change and record your observations about the change in color and the pH corresponding to it in the table as you can see on the screen. So, my young scientists, we have learned how to find the pH of a given solution, and also that the pH is an indication of the hydronium ion concentration. pH represents potence of hydrogen, that is the amount of hydrogen ions that are there in the solution. If pH of solution A is 6 and that of solution B is 8, which one has a more hydrogen ion concentration? That is the quiz for you. Which one of this will be more acidic and which one will be more basic? Now, we need to know whether this pH has some importance in our lives. Are plants and animals pH sensitive? Yes, I am sure you know that our body works within the pH range of 7 to 7.8. The living organisms can survive only in a narrow range of pH change. If the pH change is too much, then there is some disease. When the pH of rainwater is less than 5.6, it is called acidic rain. And when this acidic rain falls into the rivers, it lowers the pH of the rainwater. And this lowered pH river is not good for the survival of the aquatic life. Such rivers becomes very difficult for the aquatic life to survive. Is there acid on other planets? The atmosphere of Venus is made up of a thick white and yellowish cloud of sulfuric acid. Now, with this thick cloud of sulfuric acid, do you think the life can exist on this planet? Do you remember I said sulfuric acid is very toxic? The farmers also have to take care of the pH. You can find the pH of the soil in your backyard. The plants require a specific pH range for their healthy growth. To find out the pH required for the healthy growth of a plant, you can collect the soil from various places and check the pH, and that is the activity for you. Here is a quiz time again. Under what soil conditions do you think a farmer would be treating the soil of his field with quicklime? You know what is quicklime? It is calcium oxide, or slaked lime, calcium hydroxide, or chalk, that is calcium carbonate. So, you have to tell us that when would a farmer use these to treat the soil? Does pH has a role in our digestive system? Yes, you all know that, because in the beginning of the chapter, you had helped me in designing a remedy for stomachache. When we eat too much of fried stuff, it produces lots of acid in the stomach to digest it, and this situation is called acidity in the stomach. So, now to cure that acidity, what do we take? We take milk of magnesia. Milk of magnesia is magnesium hydroxide, which is a mild base which is often used for this purpose, or sometimes we use some antacids. And my dear students, I hope none of you is suffering from tooth decay, and if you are, that means you are not brushing your teeth properly. When the pH of the mouth gets lower than 5.5, it leads to tooth decay, because the tooth enamel, which is made up of calcium phosphate, which is the hardest substance in the body, it starts reacting with the acid and starts decaying. So, for this, my dear students, you should brush your teeth regularly, in fact after every meal. Bacteria present in the mouth produce acid by degradation of sugar and food particles that remain in your mouth after eating. That is why we say that after every food that you eat, you should brush your teeth. Using toothpaste, which are generally basic, for cleaning the teeth can neutralize the excess of acid present in your mouth and prevent the tooth decay. You know that animals and plants also use this change of pH, and this can be used as a chemical warfare of animals. Have you ever been stung by a honeybee? A bee sting leaves an acid which causes pain and irritation. The use of a mild base like baking soda on the place where the honeybee has stung you relieves the pain. The stinging hair of nettle leaves injects methanoic acid, causing burning pain. And my dear students, some of you might be living on the hilly areas and might have experienced that nettle plant has leaves which bring a stinging sensation if touched. That is because of some acidic secretion leave on your skin. And very close to the nettle plant, there is a dock plant which grows on the hilly areas. And the leaves of this dock plant have basic properties. So, if you are stung by the nettle leaves, you can rub some dock plant leaf on your skin to get relieved of this pain. That means nature provides neutralization options very close to each other. So, this brings us to an idea that nature has lots of acids. Now you can create a table of yourself and find out what is the chemical name of the acid present in the natural substance. For example, vinegar is acetic acid. Similarly, you should find what is the acid present in oranges, lemon, tamarind, curd, etc. You have found how to set up an experiment to find how acid and base react with each other. You have also found that acids and bases have got some ions because of which they conduct electricity. Now you know how to set up experiments and plan an investigation. Also, you know that whatever phenomena is occurring in your day-to-day life, you should be able to try and find answers from whatever you have learned.